All right, we're looking on page 288, 11-8, Symmetry. You've probably talked about symmetry in the past. It starts out by asking, what are symmetric figures? Okay. Aria is creating a square mosaic tile design in art class. The art teacher said to create a design that has at least 2 lines of symmetry. Does Aria's tile design have at least 2 lines of symmetry? All right, look at page 289. It says a figure has reflection symmetry if it can be reflected onto itself. The line of reflection is called the line of symmetry. So some figures have more than 1 line of symmetry, some have none. Here they're showing you that here is a line of symmetry. So that says that this side here could actually be reflected onto itself if you folded along this line. Okay, so that's 1 line of symmetry. There's another line of symmetry if you cut the shape that way. Or you could have a diagonal line this way, and if it folded, it would, or flipped over, it would have exactly the same shape and design laid on top of exactly the same shape and design, and the same if we put the line of symmetry right here. So Aria's design has 4 lines of symmetry and meets her art teacher's directions. All right, look on page 288. There's also rotational symmetry. All right, so when a figure rotates onto itself in less than a full turn, okay, so in less than 360-degree turn, the figure has what they call rotational symmetry. So these shapes below have rotational symmetry. So this diamond shape, let's say I put a line right here, okay, and I showed you the line of reflection or the line of symmetry. It would take 1/2 of a turn, or think of this as a straight line, 180-degree turn for it to have rotational symmetry or lay on top of itself perfectly. Okay, the triangle is 1/3 of a turn, or 120 degrees. So here's my triangle here, and before it's all turned to have the point over itself, if we measured it, this would be 120 degrees, because it would do it 1, 2, and 3 times, which totals 360 degrees, or 3/3 make 1 whole. This shape here, okay, I'm not really putting it down the middle, which makes it hard for you to see, but if I drew a line of symmetry here, okay, it would lay on itself. This point would be right here, okay, in 1/4 of a turn, or a 90-degree turn. Okay, so it has a 90-degree rotational symmetry. And then this sun will say, okay, say here's a line of symmetry. Well, it would be laying on itself right here, okay, and again right here. So I know 2 turns would be 90 degrees, so divide those in half, and I know it will have a 45-degree rotational symmetry, okay, because it would be on itself twice, or have rotational symmetry twice, which would be 90 degrees. So divide that in half. And then also 1/8 of a turn, because look, I could have 1, 2, 3, 4, 5, 6, 7, 8 turns of rotational symmetry there. Okay, based on what I just showed you and we just looked at, you're going to answer the guided practice questions 1 through 6 and talk about lines of symmetry, rotational symmetry also. So like for 1 and 2 it says identify the types of symmetry. So first, tell the number of lines of symmetry, or the smallest turn needed for rotational symmetry. If you could do both, that would be great. Okay, and answer questions 3, 4, 5, and 6. Bring the answers to class tomorrow along with a question. See you then.